Hello, I'm very sorry I made a mistake on the last video. Please forgive me. So the question was, there are two parts in part A. The result is that we differentiate x log x becomes log x plus 1 just using product rule. And then in part B, we have to find integration from 1 to e log x dx. So as we all know that, in order to find this, we're going to use the result of part A. So the first step, let's copy down. Differentiation of x log x equals to log x plus 1. So as we differentiate this function, it becomes a new function. Therefore, we know that if we integrate this function with respect to x, then it goes back to x log x, right? If there's no boundary, then we need to put a constant. But if there's a boundary, then we don't have the constant. So this is what I did yesterday. I tried to add a boundary from 1 to e, log x plus 1 dx. Because here we have a boundary, and therefore we need to add a boundary. And I just forgot to take a look at the other side, because if we put a boundary on x, we have to do it the same, left-hand side and right-hand side, and make a balance. Yesterday, I forgot to take a look at this part. I just cancel out the constant. I just put x log x. This is what I did yesterday. And then I try to separate these two integral into the first part and then the second part, so that we have x log x here. X. Since this is what we need to know what is integration of log x from 1 to e. So therefore, we just need to put this term to the other side. Then we can tell what is the value of this guy. So we have x log x minus 1 to e 1 dx equals to 1 to e log x dx. And this part will become just e minus 1, so that this is the result, log x dx. Okay? And it doesn't make sense, because integration with respect to x, there should be no more x here, because I forgot to put the same boundary. As we know that on equation, we have to do the same on left-hand side and right-hand side. Therefore, I make a mistake here. This is a terrible mistake. I'm very sorry. I'm so sorry. So, let me start over. From part A, we have differentiation of log x log x equal to log x plus 1. And then in part B, as we have to find from 1 to e log x dx, we use the result of part A first. So let's copy down. Differentiation x log x equals to log x plus 1. And we know that differentiate the function becomes a new function. That means if we integrate this new function, it becomes the original function, x log x. If there's no boundary, then we have to put c. And since we are looking for the integration with a boundary from 1 to e, therefore we have to put a boundary on the left-hand side, and also we have to put the boundary on the right-hand side. Okay, so that here we consider the boundary for x is from 1 to e, log x plus 1 dx. And therefore here we have to do the same. Now since it is in definite integral, no more constancy here. We just need to put the boundary, give a boundary to x also from 1 to e. And now For the left hand side, we could separate this into two integral plus 1 to e 1 dx. And there, first of all, we put e inside minus what we put 1 inside. E log e minus 1 log 1. And here, log 1 becomes 0. The whole thing becomes 0. Log e is 1. So e times 1 is e. So that we have only e left behind. Right? Now, since we are looking for this guy, so this is what we are looking for. And therefore, we should try to put this term to the other side. Becomes negative 1 to e 1 dx equals to 1 to e log x dx. All right. And here, it becomes x from 1 to e becomes this. So this part, we put e in minus what we put 1 in, so it should be e minus 1. E minus bracket e minus 1 will become just 1. And therefore, 1 to e log x dx becomes 1. Okay? So here I was so careless when I consider the boundary. I should not just put it on one side, but we have to consider both sides to put the boundary. Okay? I'm so sorry, please forgive me. I make a terrible mistake.